So we're going to start this structuring data series of two, by looking at data rectangles. We're going to use the change in Omani livelihoods over time to illustrate this. And we're going to delve into what a data rectangle is, the importance of it, and hopefully we can see, as we move to the next series, why it's important, why it's required to have a data rectangle in order to reshape your data. So just as a recap on the Omani data, this is a case study which examines survey data taken at 2 time points, and this illustrates the changing nature of farming ecosystems. The aim of the case study is to both document what's happened in the past and consider perspectives for the future. There's more information given on this under topic 1, including the data itself. So a data rectangle, why is it important? Well, a data rectangle is needed to enable features like pivot tables, filters, graphs. A data rectangle is needed as well when rearranging data in statistical software. It's actually needed to be able to do a lot of things in statistical software beyond this. What is a data rectangle? Okay, so we're going to look at the household sheet in the Omani data for this. Here we have 30 columns, which are our different variables going across, and we have 66 rows. Each row corresponds to a household's response in the survey for that year. This means that basically each row is unique for each year and household ID. So if we look at that first row, we have that the year is 2007 and the household ID is SH1. We never again in the data have 2007 and SH1. It is unique. The columns correspond to survey questions. What is your gender? What's your household size? How old are you? You know, this is our gender HH column seen here. Household size, persons here. Age, HHH, years, which is age, head of household in years. Each row gives the value for that property for the household. So each row, so for SH1 in 2007, the head of household is 55 years old. This is the person who is delegated as that kind of household head. Another really important thing to point out here is that we have only one column heading, and it's unique. We do not have more than one column heading. We just have that single row at the top for our different headers, and every single name of the columns in there are different. Nothing is repeated. Some studies can include multiple rectangles. So in this Omani data, we have 7 different sheets, and 6 out of 7 of them are actually containing a set of variables of the individuals by year. Within these 6 sheets, they are a data rectangle. We can see this because of their single row, their single column header. We can see it because the columns are all the same length and the rows are all the same width within a single sheet. It could be that one sheet is longer or wider than another sheet. That's fine. But within the sheet itself, every column in there is the same row, is the same length, and every row in there is the same width. Another quite important thing to add at this stage is that there isn't summary statistics in there. So it might be that you have, it might be that there's a data set given which looks like this format, but it has a total column in there. And therefore, a total row in there, or a mean, you know. And so it might be that you get the total number of people that remained, the total number of men and women in the household, you know, the average household size. This then means that for us to have a total column, a total row, or a summary row like this, we then have to have something which doesn't quite make sense for that row name. So say we put that row name under village and we call it all, well, that doesn't quite fit in with the rest of the structure of the data. This also can be how things turn out that you have different lengths. So if you were to calculate the totals of each column, and it was to be at the bottom, well, for village, we wouldn't have a value at the bottom because it doesn't make sense to have a village total. In which case, and similarly for year, similarly for household ID, in which case we're going to have columns of different lengths. And that means it's not a data rectangle. Now, in the Omani data, there is an example. One of the sheets, the 7th sheet, is more like a pivot table. This is animal numbers by decade. This sheet is not in rectangular format. And we can tell this because we've got 2 column names. So row 1 and row 2 are both there for the column names. And then we have duplication as well. We've got goats, 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 goats. We've got sheep again 4 times and so forth. What is the implication of this? Well, graphing tools rely on having that single column header with those unique names so that it can identify and plot the data accurately. This can be achieved a lot easier in a spreadsheet software for a rectangular sheet, such as household data, than for a non-rectangular sheet, such as our one seen here of the animal farming numbers by decade. So if we were to plot this in Excel, immediately it would come up with a problem. It would have village as its own value along the x-axis alongside the village names. This doesn't make any sense. It would give the 1988, but it's not giving 1988 goats. It's seeing goats as another value. It's seeing effectively, it's going, this is my first column. This is my row headers, and this value here just happens to be bold, but it is just another one of these values. For pivot tables, they rely on structured data with distinct column headers. With a non-rectangular format, the pivot table's incorrect. It requires manual adjustments. And filtering. Filtering can require standardized column headers so we can identify and select specific columns. This is a lot easier when there's a single column header with a unique name. Applying filters to a non-rectangular format may require customization or extra efforts to handle these variations. For example, here we tried to filter our 1988 column, and it sees goats as another value. That means that this column is no longer numeric either, which causes a whole other set of issues, or in a statistical software that can cause a lot of other problems. A data rectangle refers to a way to format the data in a clear manner. This allows for powerful tools in spreadsheet software to be easily and readily available. Other statistical software use a data rectangle for the data. Therefore, this data rectangular format is a lot more consistent with other statistical software. And this is not just R and RInstat and RStudio, which we've been using throughout this course, but you'll find this in probably most definitely in the statistical software that you're using, you'll find this. What we're going to go on to in the next video is about reshaping the data. And actually, it's really needed for your data to be in a rectangular format if you want to reshape your data. Thank you.